Now, part one of this session was all about building a small laser targeting tool, and it was all preparation for part two, which is trying to solve this problem that I've got with the machine. As you can see here, this is a side view of a piece of 10mm acrylic that was cut on my machine, and if you take a look at the left hand edge and the right hand edge, you see that they're both leaning over at about, I don't know, 3 maybe 4 degrees. It's a silly amount of error. I thought it might have been a kerf problem, but in fact it can't be, because they're both leaning the same way. If they were leaning opposite ways, then I would think it was the laser beam itself. So there's something else significantly wrong with my machine when I'm cutting thick materials. If we take a look at the y-axis, you'll see that they're pretty good. So it's only an x-axis problem. My first reaction was that possibly the laser beam itself was not aligned correctly, and as it came out of the lens at the bottom, then it was being diverted and pulled to one side. So here we've got a little picture of, here's the laser beam coming in at about 6mm diameter, and then being focused down to a point just below the lens here at about 6.5mm, and then 10mm further down, that's the thickness of my material. Now, what I was looking at the possibility might be happening is that somehow the beam was coming down here, because the laser beam was off to the side, the beam itself, the focus beam, was being diverted sideways. Now this is the nozzle off the machine with the lens in it, and I've got a little LED laser light here. I know the lens material is specifically designed to focus the infrared CO2 radiation that is emitted from the laser. I think the lens will work sufficiently well with this red light to show us the effects that we're looking for. So I've got several things to take into account here. First of all, I want the distance here to be approximately 6.5mm, and then I'm looking to get the spot into the centre of that lens, and I'm looking to get the bright spot in the centre of the red halo that's there. So that's pretty well lined up. And what I'm going to do with the marker pen is just approximately mark where that centre is. So I'm going to now move the laser to the left hand edge of the lens from the back here. So I'll now mark the centre of the shadow, and we do the same thing. We'll move to the centre the other way, and we should technically get the same amount of offset. Not a very good marker pen, but there we go. Yeah, I think I feel more comfortable with that being about 3.5 total variation. Well, having checked what effect the parallel offset is likely to have, the beam is about 6 inches or 100mm back from the lens, so there cannot be too much of an angular error before the beam hits the side of the lens. It's quite interesting because you can see in here the reflection of what I'm doing with the light source, and then you can see the light source on the lens here, and you can see the result on the projector at the front there. I'm approximately 100mm back now, so let's line things up. I can make a small difference to the position of the light at the front there. In fact, the light itself is staying pretty close to, I would say it's less than probably a millimetre of its position. So I think what I conclude from this is that no matter how badly the last beam is lined up relative to the lens, it can't be very far off angle, and any angular error that I'm likely to produce on the beam, because it's off centre to the lens, is going to be probably less than half a degree. Well, here we are at the back of the machine. I've used a piece of sellotape here to stick this flat back onto the surface of my water jacket here. I'm making a pretty bold assumption that the water jacket is true and square with the axis of the laser, more or less. Now if we look closely just here, you'll see that I have got a piece of sellotape which is holding this back and passing right across the front of the window. I want to make sure that I keep this as flat and as uniform as possible. I don't want it to move. The little location spigot on the inside, that does a great job of centralizing it that way, but it doesn't necessarily control it that way if there's any sort of clearance. But a flat surface, which I've turned on there, nice and square, will ensure that this sits in line with the axes of everything. My beam is basically pretty well lined up. This is working properly and approximately lined up. I should be able to see my red beam going through here, across the machine, down through the mirrors and coming out the bottom of, not the nozzle because I've got the nozzle off at the moment, but we should see it appearing on the table. If you watch carefully down there, you'll probably see the red light come on. Here's one of the little targets I made in one of the earlier sessions. We'll just drop that into the opening here. It's probably a little bit difficult for you to see from this angle, but as I move my head around, I can see that that beam is actually pretty well central to the crosshair. So I'm very pleased with that alignment. Now mirror number 2 is going to be very difficult for you to see. Although this is not a true mirror, it's reflective enough for you to see the actual spot. Let's see whether or not I can adjust that now with that rear mirror to come onto true centre. And I should be able to do that hopefully quite easily. Let's just loosen these lock nuts off a bit more. So I want to steer the beam a little bit further towards me. So it's the most difficult one, which is the bottom back one, which I think I want to get to adjust, and that is incredibly difficult to get to. I think the only way I'm going to get to that is with a pair of pliers. So what I've got here is a pair of pliers with some grippers on the inside. It gives me a chance of getting on there and making some small adjustments. Look, and as I twist that, I can steer it onto centre. Now I need to come down a shade, which means I need to turn this top one slightly. And there we go. Spot on centre. Well, that was pretty easy once we got the adjustment sorted. So the beam is still on the side there. So what I should be able to do now is to adjust these manually to tweak that one right into centre, and then we've got to get it up and down, which we should be able to do with the top screw. The top adjusting screw should give that to me. And there we are, look, spot on centre, just like that. It's unbelievable. And the end result is that we should have a beam coming out the end of the nozzle, which we do. Let's turn the lacer off because we don't want the lacer on. We'll turn the water pump off because we don't want the water pump off. We don't want anything on except the power. Right, so we'll just turn the power on now. And when I turn the power on, the head is going to go into a reset. So I need to remove any crap that I've got sitting around the machine, because I need to wind the table up, and to do that I've got to have power on the machine. Check, check and check again. Everything is off except the power. We'll turn the power on and it will go into a reset. And then we can just drive the head back again to where we can see it. There we go. Now what we're going to do now is to bring the table up. I've used my big target here, and we just drop the nozzle holder down over it so that it's central. And then we'll lift the nozzle holder up again and tighten it up. And then we'll check the position of the dot. It is not central, but now it should be just a fairly simple matter of adjusting these screws on the head here. There we go, so we've got the right grub screw now. So we just loosen these screws off on the head here, these locking screws. And now we should be able to adjust the screws on the head and steer to centre. Can't go any more that way, so I'll have to take both of those. That's pretty well on centre. So finally what I'm going to do is just go to the four corners of the machine where they recommend you should test this. We can power it to the corners. And we'll just make sure we've got a clean little red spot there. And then we'll take it to the other extreme. And we've got a little red spot there. Now we'll come to the front corner. And we've still got a nice little red spot down here. Front left-hand corner. And sure enough, it's there as well. That hasn't stopped us having a great success with this new toy. In trying to find out why I was getting this pretty significant angle on the side here, like this, in the x-axis, it's pretty obvious now I see it. But if you take a look at the head, you'll see that the head is way out of line. And in fact, when I put a square on my work table, and this is a 1mm thick piece of wood, look, the best part of 1.5 mm at the bottom here, that's a long way out of square. I'll set it back to square and just tighten these two screws up. Now, the problem with having adjusted this head this way, I possibly could have messed up my mirrors. And that's now the great advantage of having this dynamic red beam system. So I'll just push that to an extremity, drop my target in. But it's not that far off centre that I think I need to worry. I mean, I can very easily, to be honest. I don't see why I should be even concerned, because all I've got to do is just let me think which way the mirror's got to go. It's got to come undone. So I can just loosen this bottom one off very slightly, look, and just like that I can put it straight back onto target. And then when we take this out, look down on the table there, and there's our spot still there. No more worries about mirror alignment. There was a time when I thought, well, I might leave that little adjustment. It's near enough. It doesn't have to be near enough now. I can get it spot on. Now we're going to have to go and just test the machine with a real laser, and to make sure that everything is working okay. And the quickest and the best test for that is to come down here to the nozzle. So we've just removed my little red laser pointer from the mouth of the laser, and we're okay to now power up the machine again. We'll turn the air assist on, because I don't want to cause smoke to go up into the lens. And now we'll raise the table. Now this is my preferred method, a nozzle test. Use a piece of soft wood, this is plywood, and I've just clamped it between the head and the table, and I'm just rotating it. Okay, now we'll do a pulse test, and you'll see the smoke. Oop. Drop the table down, and I hope that you can see there that what we've got is a hole, not perfectly in the middle, but sufficiently in the middle to not worry me at all. We're just a little bit high with the focus point. We're probably about 7mm, maybe 8mm, and I didn't set it. Now that's good this time, because look, you can see clearly we've got some bend away and some bend away, and now we turn it through 90 degrees, and this is where we had our squareness problem. I would say we've now fixed the squareness problem. So it was all a matter of the squareness of the head to the table, and that may well be something that moved in transit and I never bothered to check it, or it wouldn't have shown up unless I'd been doing this very, very thick work.